Hi everyone, I'm Won Lee. I'd like to continue hypothesis test for population mean mu. Two-tailed test, this one, we derived rejection region for H0 for this, right? Okay, I'd like to add one more thing, one-tailed test like this, a little today. All right, let's review a little about two-tailed test, this one. And at significance level alpha, alpha, you know, is a small value, something like 0.05, 0.01, 0.001, something like that, small value, alpha. And rejection region for H0, this one, H0, is sample mean is less than mu zero. This is a base value or reference value. Mu zero minus this much, or x bar sample mean is greater than mu zero plus that much, this much, then we reject H naught. Why? For this value, less than mu zero minus t alpha t times s over square root n, this one, this value is a little far away from mu zero, reference value mu zero. Understand it? Okay. If sample value is that far from mu zero, this far from mu zero, then there is significant difference. Okay, and I hope you understand this uh, procedure, But if you cannot, then that's okay. Okay, because it is some complicated or mathematical. It is a simple equations, but somebody dislike this kind of equations. Okay, continue. The graph below this one shows the distribution of a sample mean x bar. Okay, sample mean x bar. There are many small x bar here. Then it will has normal distribution by central limit theorem. The center is mu zero. Okay, because the process of hypothesis test starts under the assumption H0 is truth. Okay, H0 is truth means mu equal to mu zero. That's why another reason. That's why equality sign is in H0. So there are many small x's here, but mu 0 minus t alpha over 2 s square root to n, that much, mu 0 plus t alpha over 2 s over square root to n, this distance, okay, far away here. If you realize the sample mean x bar is here, lies in these areas, then you may decide, okay, small x bar, you obtain the sample mean is far away from mu zero. So these two areas, sum of two areas equal to alpha. What is alpha? Alpha equal to h naught through given h0 what reject. That is alpha, right? H0 true means mu equal to mu zero. But when you observe calculated sample mean lies this area, you can say there exists significant difference from mu zero. So you reject H naught. You reject mu equal to mu zero. So you make error, right? Because this one, under the assumption mu equal to mu zero, this one can, you can get some sample mean here. So you reject H naught, then you made error. That is type 1 error, right? In other words, the rejection region for H0 is determined by the range where the calculated sample mean, small u or small x bar, from the observed sample values is less than this value, greater than this value. Rejecting H naught means that sample mean x bar falls within rejection region, as it shows x bar has a significant difference from mu zero. The area probability of these rejection regions due to two-tailed testing is precisely significance level alpha. Okay, so these two values, this one and that one, are referred to as critical values. It is critical because uh, it is these these values serve as boundaries for making entirely different decisions. It is critical values. Get it? All right. However, it is not reasonable to make different decisions simply because the sample mean x bar differs slightly from the critical values. So it is not reasonable. I mean, okay, here, if you get x bar here, okay, you what? You reject h naught. If you get this value, x bar, then you cannot reject h naught. So it is not reasonable because a small difference from critical value, what I'm saying. Okay, so we will use, say, p-value, significant probability. Okay, I will tell you maybe next time. Now, one-tailed test for population mean mu. I took this example before. One-tailed test for lifespan of an electronic device. Electronic device, the company want to test this kind of a thing. H1 here, H1 is mu less than 2000. Previously, the lifespan is 2000, okay? But they want to reduce production cost by replace some part, okay? So they doubt, oh, the lifespan becomes less than 2000. They worry about that. So they can test this kind of a one-tail test. Test statistic, it is what? For mean mu. So test statistic is x bar. Rejection region of x bar is what? X bar is less than 2000 minus some value. Understand that? You don't worry about greater than 2000 because you reduce production cost, then you worry about lifespan is less than the usual lifespan time, 2000. Okay, the rejection region for H naught is 2000 minus T alpha, not alpha over 2, times S over square root n. This one. I hope you understand why. Since this is a one-tail, left-tailed test, the significance level alpha is placed only on left side. Alpha is over here. You should not divide alpha right-hand side here. Okay? Only on left side here. So left side hypothesis testing. Okay? It is not complicated, but I don't know whether you understand this one or not. I hope you may get it. Okay, that's it today. Thank you. Bye.